To page 20 in your packet and try the warm up now. Pause the video while you try these two problems. Okay, so to find a whole of a rational function, we have to factor the numerator and denominator. So the numerator is a difference of perfect squares. That's x plus 10, x minus 10. The denominator has a greatest common factor of x, and I'm left with x plus 10. And the factor that divides to 1 gets us the x coordinate of the whole. So when does x plus 10 equal 0? That's when x equals negative 10. So we now get the y coordinate of the whole by using the compressed function. So our compressed function is what's remaining, x minus 10 over x. So we have to take this negative 10 and use that as the input in the compressed function. So that gives us negative 10 minus 10 divided by negative 10, which is negative 20 over negative 10. So that's positive 2. I'm going to do the same thing on number 2. The numerator, what multiplies to negative 20, that adds to negative 1, is going to be x minus 5, x plus 4. The denominator, because we're specifically finding wholes, some factor should divide to 1. So I'm going to take this denominator and maybe, hopefully, one of these factors is there. So I'm thinking 28, that doesn't have a multiple of 5, but 28 divides evenly by 4. So if I do x plus 4, x minus 7, 4 times negative 7 is negative 28. 4 plus negative 7 is negative 3. That works. So the factor that divides to 1 gets us the x coordinate of the whole. So now the compressed function, I'm going to input negative 4 to each x. And now simplify. So negative 4 minus 5, negative 4 minus 7. Negative divided by negative is positive. So we get negative 4 comma 9/11. Ooh. Okay. The homework answers from the prior homework, make sure you checked in Drive. And today what we're going to focus on is identifying slant or oblique asymptotes. To find slant and oblique mean the same thing. So to find a slant asymptote, we have to divide polynomials. And it was about a 50-50 split of method preference between box and long division. And usually, especially with these graphs, the way we're going to analyze them, the division problems here will be written in fraction form and not just division form. So to review division, I will first let me rewrite this. Okay, I will do one of these problems with box method and the other with long division. You can pick your favorite method either anytime. You do not have to do one way or the other. All you need to do is pick your favorite. So for number 1, I will review long division. So I've got the divisor and the dividend. And the quotient, which is our answer, what we're going to get up here, that's going to, in our graphs, be our slant asymptote. When we're just doing a plain old division, there's going to be a remainder likely. When when we apply this to slant asymptotes, we will not care about the remainder. Okay, first step is have a division thought. I'm going to take m squared and divide by m. That's m. Line it up. Multiply back. M times m times -8. Subtract, subtract, subtract. So that's negative, that's positive. Bring down and repeat. Have a division thought. M divided by m. It's 1. Multiply it back. M times, nope, sorry, 1 times m. 1 times -8. Subtract. We get a remainder. And so in this case of just pure division, the answer is quotient plus remainder over divisor. When we apply this to slant asymptotes, I'm only going to care about that quotient. All right, for box method, we set up a box, and the divisor gets us the rows, so x plus 6. The dividend is going to get us the diagonals. So I start at the first line, it's going to get to x squared. Then 5x gets in the corner. So now I need to add a column for the 3. All right, first step. The first term gets replaced in the first box. X squared divided by x equals x. So technically what you're doing is you're figuring out length times width, x times x, which was here, fills in the area of that corner. Then we then we multiply back. X times 6 is this area, because it's x for the length, 6 for the width. And then we subtract, because this diagonal has to add up to 5x. So you can make it a puzzle, or you can say what plus 6x makes 5x, or I'm going to subtract backwards. 5x minus 6x is -1x. Divide again. -1x divided by x, -1. Multiply it back. Subtract here gets me the remainder. And so the division answer is quotient plus remainder over divisor. Okay. As a process, we can find slant asymptotes with division. Poles were good. To find a slant asymptote, we are going to use division to find that equation. So we had said earlier, there is no horizontal asymptote if the degree of the numerator is greater than the degree of the denominator. And when that situation happens, there is a slant asymptote, which is not horizontal. So we've got problem number 1 here, and you can see the degree in the numerator is 2. The degree in the denominator is 1. So the numerator degree is bigger than the denominator, which creates this green line, which is a slant asymptote. It is not diagonal. Make this a little bigger. So you can see our end behaviors, instead of the end behaviors approaching a horizontal line, which looked like this in our prior graphs, now these end behaviors as x goes to infinity is approaching this diagonal line, some linear equation. So here's how we find the slant asymptote. Pick your favorite method, box or long division. I think I'll do box for the sake of space. Okay. X squared goes back. X squared divided by X. Multiply it back. X times -2. Subtract. If you want to write it out like this, minus a negative becomes adding. Divide 5x divided by x. I'm not going to go the extra step for the remainder because now the slant asymptote is the line x plus 5. This is your slant asymptote answer. You need a y equals to show it's a line. And here's the line, mx plus b. It's that green, this specific green linear equation. So look, here's the y-intercept of 5. And it goes up 1 over 1. So up, here's up 5 over 5. Or up 1 over 1, up 1 over 1 for the slope. All right, let's try number 2. Find the slant asymptote for number 2. This time I'll do long division. If you like box method, you stick with box method. Pause the video here and see if you can get your the answer to the division, the quotient, before you watch the solution. So I'm going to have a division thought. 3x squared divided by x is 3x. Multiply it back. So 3x times x, 3x times 2. Subtract. 1x, bring down. Have a division thought. So x divided by x. Multiply it back. I actually don't even have to do this step. I don't care about the remainder. So here's my slant asymptote. Did you get y equals 3x plus 1? Okay. Now we're going to put it all together. I need a little more space. So pause the video here for number 3 and see how many of these properties you can find for number 3. All right. I'm going to start with A, domain. First, I'm going to actually factor that denominator because that's going to help me. What multiplies to -6 that adds to -1? I think I'm going to use 2 and 3. -3, +2. Oh, there's going to be a hole. Check that out. So my compressed function. Okay, let's do domain while I'm at it. So the denominator can't equal 0. So that means x plus 2 can't equal 0 and x minus 3 can't equal 0. X cannot equal -2. X cannot equal 3. So the domain is all real numbers. X cannot be -2 and x cannot be 3. Part B is the holes. So since this factor eliminates, when does x plus 2 equal 0? So the x coordinate of the hole is -2. Input that to the compressed function. And that's -1/5 for a y coordinate. Vertical asymptote. Well, let me circle my answer. What the remaining denominator of the compressed function will get us the vertical asymptote. So when does that remaining denominator equal 0? Is x equals 3. Horizontal asymptotes. I'm going to compare. So I can either compare in my original function or the compressed function. The numerator degree is smaller than the denominator degree. Oops. That means there's a horizontal asymptote of y equals 0. Because there's a horizontal asymptote, there are no slant asymptotes, so E is none. Okay, now we need x and y intercepts. Let's do that down here. Same problem, now I can just see my equation. Oh, no, sorry about that. Okay, for x-intercepts, that is when the y-coordinate is 0. So for x-intercepts, that's when the entire equation equals 0. I'm going to multiply both sides by the denominator. Zero times anything is 0. So the x-intercept is the point -2, 0. This was part F. Was F x-intercept? Nope, that's part G. Sorry, I did them backwards. Part F, the y-intercept is when the input is 0. So I'm going to make every x 0. That gets me 2 over -6, which is -1/3. So the y-intercept is the coordinate 0, -1/3. No, I didn't circle my answers. X-intercept, y-intercept. No slant. Okay. Your job now, oh, I just did that one. Oh, of course I gave myself extra room. Okay, sorry. Your job now is pages 23 and 24. Get all the properties. Oh, look at that. This has range and end behavior. We should do that for number 3. Let's do range and end behavior as well here. Okay, sorry. Scratch that, rewind, go back to 22 at the bottom. Let's do range. H. All right, so the range is y cannot equal the y coordinate of the whole, -1/5, and y cannot equal the horizontal asymptote, so y cannot equal 0. For end behavior, let's do right end behavior, left end behavior. End behavior, when you have a horizontal asymptote, will always approach the horizontal asymptote. So as x goes to infinity, y goes to 0. Left end behavior, x goes to -infinity, y goes to still 0. So your